The Maslow 4 automatic calibration process is something that hasn't really been done before, so we're continually improving and changing how it works. So this is an updated walkthrough of what that process looks like as of firmware version 1.04, which is the latest one. First of all, we'll start out with, I'm going to turn the machine off. I'm just going to plug it back in. If I had an e-stop button, I would just use that. But basically, it's always best to start the process from sort of a known state. Ideally, it would be robust starting from any state, but just to make things smooth, let's start out from the machine has just been powered on. Jumping back in time from the future here, the calibration process expects the z-axis to be all the way down. It was already all the way down on the machine at the office, so I forgot to mention it, but it's important that you remove the router bit if you have one in there, and then lower the machine all the way down. So to do that, what we're going to do is first we're going to click on alarm here to unlock the machine, and then we're just going to click the down z-axis button. And we're just going to keep doing that until we see it fully bottom out here like this. And that's going to make the machine more rigid during the calibration process, and also the machine needs to know exactly what height it's at, and it does that by zeroing out on that bottom surface there during calibration. You also have the option to, if you ever want to reset that sort of bottom Z height, you can do this set Z stop button here. All right, back to the office. And here we can see the machine has just been powered on. So what we're going to do first is we're going to hop here into setup, and we're going to click on config. And we're going to config a couple of different settings here. The extend distance, this is how far out the belts will extend. Basically, we just need this number to be big enough to allow them to fit on our frame, but not so big that it's like there's a lot of extra looseness. The orientation is vertical. Vertical is the frame is tilted up like this. Gravity's pulling the machine down. Horizontal is if it's flat on a floor. Next, here we have our calibration grid settings. So this is how many points the machine is going to use to calibrate. Here we have it set to 3 by 3 points. And we have the calibration grid size. Here we have it set to 500 by 500. If you're having issues with getting calibration to work, I recommend starting with pretty small settings like this. So 3 by 3 in a pretty small area. You'll get better accuracy using more points in a larger area, but it's just easier to run on a small area with a small number of points. Finally, down here at the bottom, we have 2 forces we can set. Retraction force is when we do retract all and retract the belts in. That's how hard they're going to pull to retract themselves in. And calibration force is how hard it's going to pull on each belt when we take each measurement. These settings all look good for my machine, so I'll press save here. And then I'm going to do retract all. And now you'll notice my belts are actually already retracted all the way in. I'm still doing retract all just because that lets the machine home. We powered up, we didn't know what state it was in. We pressed it retract all, now the machine knows the belts are retracted. A quick editor's note here. This is what the belts look like when they're fully retracted. All of the white part is wrapped up in the center of the machine. And if you're having a hard time getting them to retract, you can either press retract all again, or you can increase the retraction force in the settings. Then we'll press extend all here, and that's going to allow us to use our rocking motion to start extending our belts. They are going to simulate being compliant while they're extending out. So you can see if I stop pulling, they'll stop extending. But what we want to do is just provide a nice constant pressure to help the belt unspool. And this is going to unspool that amount of belt that we entered for the distance. So in this case, it's going to unroll 1,500 millimeters of belt. The very first time you do this and extend the belts and go to set them up on your frame, you may discover that you haven't actually quite extended enough. and it can be frustrating to have to start the process over. So as of version 1.04, we can actually just go back in here, and I think my frame needs 1710 to actually fit on there. So we can just come back here, press extend all again, and the machine will now let us extend out that extra bit of belt that we need. That's totally optional. I just wanted to point out that if you accidentally don't extend enough belt to reach the corners on your frame, you have the option now to just extend more without restarting the process. Next, we're going to hang the machine on our frame. And the machine is now roughly centered. I happen to know that 1710 was right about to get my machine without too much slack in these lower belts. If there's a little more slack, not a problem. Now, we can press the calibrate button. And our machine is now going to take up the slack in those lower two belts. And it's going to take an initial measurement here in the center. And this initial measurement is actually going to take twice. It's going to take once at a lower force, and then the same measurement in the same place again at a higher force. And that's going to allow us to measure how much the frame is actually flexing. We're not really doing anything with that number right now, but it could be valuable for the future. You can see that as it's the first points here, it's moving. It's leaving these lower two belts completely slack. And that's basically because the machine does not know how big its frame is yet. So it doesn't have enough information to fully constrain its motion. So it's using the upper two belts to position itself, and then the lower two belts are slack. And it's going to do that because we set it to vertical mode. So in vertical mode, it will always use the upper two belts to move itself around, and the lower two belts are going to be slack when it's moving, at least for this first set of measurements. So now the machine has measured its first set of waypoints. You'll hear the cooling fan turn off, and you'll see it begin doing some calculations on the computer. When the calculation is complete, now the machine will move to take its second set of waypoints. And now you can see the machine has enough information that it's able to move with the lower belts tight. This will be slightly different in horizontal orientation. I'll show that process after this finishes. So now the machine is going to move through a second set of measurements. And the machine will be spiraling out from the center. So we just have it set to do a 3x3 calibration, which is going to be 500 by 500 millimeters here. If we had to set to do, say, 5x5, it would do a 3x3, and then it would recompute, and then it would do a 5x5, and it would recompute. This process of computing the calibration actually runs on the laptop itself, or whatever computer is controlling the machine. It doesn't run on the machine because we need more processing power than the machine itself has. And that means that the speed of this process is going to be controlled by how powerful the computer you're using to control it is. So it'll go much faster on some computers than other computers. It's also important that this browser tab stays open through the whole process, because if I were to close this browser tab, it wouldn't be able to compute anymore. So now the machine will move back to the center, And when it gets to the center, it's going to compute the calibration one more time. So that's it. We're fully calibrated now. You should not have to run this process again. There's a pop-up that'll tell you that. If you leave this pop-up open for too long, it'll give you like a disconnected message. You can ignore that. It's a bug. But you should never need to run calibration again. That's it, unless your frame changes size. Next time you go to set up the machine, you can just extend the belts and press apply tension instead of calibrating. That'll just take one measurement. It'll check that against its internal calibration and say, okay, that measurement matches up with what I expected. At this point, you're now ready to move the machine around with the arrow buttons, or run a file, do anything, use it totally normally. Now we're going to walk through the calibration process in the horizontal orientation. Again, the machine has just been turned on. The first thing we're going to do is we're going to lower the z-axis all the way down with no router bit in the router. To do that, we're going to click on alarm, and then we're just going to keep lowering it down until we hear it bottom out. Got pretty close, but it needs to go a little further. Great, so now it's all the way bottomed out at the very bottom, no router bit in the router. Now again, we're going to go in here to setup. We'll look at our configuration. We've got our extending distance here. This is bigger because this is in my garage, which is larger. We've got horizontal setup. This time I'm going to do an 8x8, 7x7 grid just to show something different this time around. And I have these numbers quite a bit higher for this machine. It's a little bit stiffer than the other one. So we'll go ahead and save that. Then you can see we're starting at an unknown state. We'll press retract all. The belts are now retracted. Then we'll do extend. Now we've got the machine laying on our spoil board here, and we're going to extend our belts out, attach them to the four corners, making sure there are no twists in them. Now that we've got all four belts hooked up, I'm going to give the machine a little bit of a tug here, just to put a little bit of tension on those top two belts. This side is the bottom that has the dust collection port on it. And that's just because I know when I press calibrate, it's going to expect these top two belts to be pretty much tight, and it's going to pull up the slack in these lower two belts. So I think that just helps the machine start out sort of more in the conditions it's expecting to be in. And you'll notice that my machine is not particularly centered here, and that's okay. So now I'm going to come over here and I'm going to click calibrate. And you'll see how the machine moved there a little bit. That's just it. Basically the servo motor is powering on in those top two motors. But now it's really going to pull tight on these lower ones. And again, I kind of like to just give it a little bit of a tug there, just to make sure these top two ones kind of stay tight. Great. And from here on out, the process should be automatic. We're taking our first measurement. Now you'll see different than in vertical orientation. In horizontal orientation, the machine is using the two belts that are sort of the direction it's going to pull it along, and the other two belts are slack. You'll notice the machine is spooling out some extra slack here as it moves during this step. The upgraded belt guards mostly do a good job of keeping the belts out of the gears, but it is worth keeping an eye on it and making sure it's not like too excessive. Here we can see the machine is going through the process of calculating an initial guess for where the anchor points are. Basically, it started out not knowing anything about where the anchor points are, and now it's refining that understanding of where they are. It looks like this time the process is probably going to succeed the first time through. You can see once the number starts ticking up pretty quickly, that usually means it's found like a pretty good initial guess and it's refining it. I have seen this process fail and then automatically restart up to like 10 times before it gets a correct answer. So if you see it fail, that's totally normal. It'll try again with a different initial guess. Oh, no, it looks like it's going to get stuck. All right, so there you can see it failed, and now it's trying again. Failed again, it's trying again. Failed again. Here now it's trying again. All right, this score is going to be high enough that it's going to be able to proceed on to the next step of calibration. If you're really interested in what's happening mathematically here, basically when we have a very small number of data points, there's these things called local minimas, and basically the process can get stuck in a place where it sort of can't find which direction to go to get better, so it just sort of randomly needs to try somewhere new. Now the machine is going to move to the center of the sheet, and now it's going to start running the grid that we actually set it to run. Now the calibration process of determining the anchor points is going to repeat again, but using the additional information we just got from that next set of data points. So now you can see the machine has updated its understanding of where the anchor points are, so it feels safe to go a little bit further out. And our first grid was 3 by 3. Now it's going to do a 5 by 5, and then it'll recompute again, and then it'll do a 7 by 7, and then recompute again. All right, the camera battery died there, but you didn't miss much. We're just taking more measurements. Now again, here the machine is going to take in all that new information, it's going to process it, and it's going to use it to refine its understanding of exactly where those anchor points are even better. So this should be our final grid. We're going to go around and do a square with 7 points on each side. So this is interesting. You actually just saw it fail there on the final pass, which is somewhat rare. But it will happen and it'll still restart, and you can see now it's going to pass. So at any point in the process, if it gets stuck in its calculations, it will restart and hopefully get itself unstuck. Now the machine is going to move itself back to the center and calculate one more time, which should be pretty quick, and that's going to be our final calibration. We'll be done. We should now hear there the cooling fan goes off for the last time. The calibration just does one final double check to make sure it can't make any more improvements. And we'll get a pop-up here letting us know that our calibration is complete. So now we can move the machine around. And we could raise up the z-axis. And if we wanted to, we could put a router bit in there and start cutting things. That's it for the whole calibration process. I can't think of anything else I missed, but if you have any questions, let me know in the forums and you should get an answer pretty quick. All right, thanks for watching.